Hi, good morning, everyone. It's 10 o'clock, and thanks for joining the webinar. We're going to wait just another 30 seconds or so to allow people to join if they need extra time. Could use some good hold music, I think. For those of you joining, we're going to give just a little bit more time for folks to jump on the webinar and get ready, and we'll kick it off here shortly. Okay, well, it's been a little over a minute here. It's shortly after 10 o'clock on the West Coast. And let's go ahead and get the webinar started here. Why SAS is a gold mine for crypto. Hello, everyone, and welcome to the webinar, Why SAS is a gold mine for crypto. My name's Cameron Brett with the SCSI Trade Association, and with me today is Jonmichael Hands. He's VP of Storage Business Development for Chia. Today's webinar, we will have an overview of Chia and proof of space and time for crypto farming, and why SAS is a really great technology for this type of crypto. Quick housekeeping items. If you'd like to ask a question, please type in the chat box and we'll answer questions at the end of the webinar. Also a request to please provide feedback and rate this webinar after we're all done. So just a quick look at the SAS storage. The blue, yes, that's all SAS. SAS has been the tried and true storage interface for data centers for decades. And according to IDC, this chart shows the amount of storage capacity that'll be connected via SAS through 2025. What makes this so large? SAS has the capability to connect SAS and SATA hard drives, as well as SSDs. The majority of the SAS connected storage here, of course, will be SAS and SATA hard drives, and likely that PCIe-based SSDs will be the preferred. They'll be preferred for fast storage. Not only is SAS used in the traditional enterprise data center, but it is also used in hyperscale deployments, typically where hard drives are used for vast amounts of data storage. This is a quick chart. I won't spend too much time on this, but here's a quick look at the SAS, SATA, and PCIe interfaces. As you can see here on a single lane basis, that one lane peak bandwidth column, 24 gig SAS provides the highest bandwidth with the exception of PCIe 5.0 at 32 gigatransfers per second. The bandwidth numbers shown here are the raw interface, are at the raw interface level, but they do account for the encoding overhead, which you see in the interface column there. It does not account for protocol overhead and what each specific vendor's SSDs may experience as their own when they design their own SSDs. SAS still offers some very good performance options with SSDs if the storage fabric needs to be all SAS and you cannot integrate PCIe SSDs. And here's a closer look at the actual connectors used for specifically for SAS deployments, and it's based on the generation of SAS. This may help you select the proper cables needed for SAS architectures, so you use the right cable for the right generation of SAS. Also wanted to point out the link at the bottom here where you can download a recently revised SAS Integrators Guide, which was recently updated by Alex Hazer of Molex, who's also a SCSI Trade Association board member. It goes into more detail and is a great resource for connecting up your SAS deployment. And without further ado, I'd like to turn it over to Jonmichael Hands to talk about Chia and SAS as a great storage technology for this type of crypto farming. All right, Jonmichael, it's all yours.
Hey guys, this is Jonmichael. I'm the VP of Storage at Chia. My former life, I was at Intel managing the data center SSD product line. I actually joined Chia in May to talk about storage. And so I work very closely with the storage vendors in the industry. Cameron and I know each other from a long time ago, all the way back from SAS and NVM Express. But so today I was going to talk a little bit about, the first thing I was going to talk about is an overview of Chia farming. So before we talk about where Chia makes sense in SAS, it makes sense to talk a little bit about Chia for those that aren't familiar with Chia. So Chia is a cryptocurrency that uses something called proof of space and time. And this is the consensus mechanism we actually use to secure the network. And you can think of Chia, it's kind of like Bitcoin, but with hard drives. That's how I explain it to people that aren't really into crypto. But it's really something more special than that. So you do the work up front, and then you store it on the drives. And this is really effective from a power utilization standpoint. So this makes it very power efficient compared to proof of work, which is out there today. As you know, like Bitcoin uses SHA-256 for proof of work, and they make these high power ASICs. And then Ethereum uses like graphics cards and other, there's also ASICs for Ethereum to do mining, and that's super energy intensive. So the whole idea for Chia is it's a more eco-friendly cryptocurrency because it uses storage. And storage is energy efficient because you can store data on storage, and then it's non-volatile memory. You can turn that media off and you turn it back on and your storage is still there. So, storage can be very power efficient depending on how frequent the access is. And like your phone and laptop do this all day, every day to save battery life. When your drive is not being used, it just goes to sleep. And then when you need the data, it wakes it back up real quick and grabs the data. So in Chia, you have these things called challenges that come from the verifiable delay functions. In Chia, this is the proof of time in the proof of space and time. And this verifiable delay function basically calls out this challenge. And then a farmer will look at all these plot files on their hard drive. And we'll talk a lot about those in a few minutes. But you'll basically look at all these plot files in your hard drive and see if you have one that meets the challenge requirements to see if you're a winner. If you are finding the winning proof, you can be in the next reward block, and you can be part of the next block that actually in the blockchain creates the transactions. And if you are lucky enough to be this person, every 10 seconds there's a new challenge that's called out that has a winning proof, then you get 2 Chia as a reward. And so people are financially incentivized to basically store data on their hard drive in basically securing the network. And because of this is a kind of low barrier to entry for crypto, because people don't need like super high-end equipment to farm Chia. You basically just need a hard drive and a desktop, and you can go start farming. Now, as you can see, that quickly moves from people doing the lowest node that people can farm Chia on is like a Raspberry Pi 4. That's kind of our baseline for what the minimum node requirement is Raspberry Pi 4. But people are using extra storage space that they have on their desktops. There's a lot of people that just have like an extra USB drive. IDC did a report on Chia earlier in the year, and that's up on you can find the link to that on chia.net. But basically, they suggested that the average consumer is only utilizing about 20 to 30% of their hard drive. And that means their internal or external hard drive. So that's pretty interesting. That means there's a lot of people that just have extra storage space laying around in their NAS, in their external USB drive. And that makes sense, right? You can buy, I think on Black Friday, you can buy a 14 terabyte USB drive for $200. So, people are buying more storage than they need. And this is kind of a cool way for people to financially incentivize extra storage they have laying around and be able to earn some rewards by putting it to the Chia network. And so we have some people that are just using, a couple terabytes that are just using desktops. There's a lot of people that are using consumer NAS, and I think of a consumer NAS as kind of like a mini JBOD. These are really integrated storage boxes. They have power, they have cooling, they have drive slots and LEDs and notifications, but they're meant to be low power and they're meant to be idle quite a bit. And you'll see as soon as people start moving from tens of terabytes to hundreds of terabytes, they quickly figure out that SAS and JBODs and SAS infrastructure is really where they want to go. So the data center has kind of solved these problems of basically like, how do you store a lot of data in a small amount of space and have it accessible to a user? So JBODs kind of solve these problems of, it is an enclosure. It has these things called enclosure management in SAS, where you can notify and identify a certain slot this is really helpful if you have a drive that fails. You want to be able to say, hey, what slot is that in? So I can send a technician out, or if I'm a Chia farmer, I can go identify, light up the LED on the JBOD and actually pull out the drive that failed. JBODs also have fans, and they have integrated fans and enclosures and power supplies in there. So all you have to do is pop the drives in. And a JBOD has something called a SAS expander, which is really critical to the SAS ecosystem. And we'll talk a little bit about the SAS components of like what you need from SAS specifically for Chia farming. But the fact that you have a SAS expander in a JBOD, and JBOD just stands for just a bunch of disk, if people are wondering, the fact that you have a SAS expander in it means you can connect a whole lot of drives with just one cable. And that's super important, right? I think people that are doing this DIY stuff for Chia, and they're connecting dozens of hard drives to a desktop, quickly find out that it's a pain in the ass to basically hook up all these different SATA drives, individual SATA cables, and the power connectors. ATX power supplies have to be really flexible for stuff like 12 volts. Hard drives happen to need 12 volts and 5 volts. And so it gets a little tricky when you're trying to do the power calculations on the SATA power connector. You really can only support 4 drives with the typical ATX power supply. And so SAS JBODs kind of solve all these problems, right? It's a kind of a nice house for all the drives. And Chia farmers that are going to petabyte scale, that we have a few people in the community that are doing this now, quickly figured out that this is the right way to go. Now, before you actually store the plots on these hard drives, they have to be created first. And when they're created, they use temporary storage and compute and memory resources to basically create these plots. So this is in Chia, we call this the proof of space construction, but this is what makes this actual file very secure. And then the work has to be done up front so that later when you're reading that plot file, it's very quick and efficient. And what we've done is when you're doing the work up front, that makes the IO and the CPU requirements when validating the proofs almost nothing when the plot files are done. They basically just sit idle on the hard drive. But there is some work up front you have to do. And I'm not going to spend a ton of time talking about this today, but we have done a lot of presentations on this at Chia you can go check out. But basically the way that a plot file is determined is you have this K value, and a K value on the network today, we have a K equals 32 as the minimum size of the file on the network. And these files create these 108 gigabyte files, or 101 GIB. As the K goes up, each of these, in these plot files, they have these cryptographic hashes, and there's 2 to the K power of entries per table. And so as you increase the K value, the files get bigger and bigger. And you can have really big files, but most people just do K equals 32, which is the minimum size, and you have a bunch of these 108 gigabyte files. You can kind of see, here's a screenshot of my desktop with just copying the files over. But this is really important because once the files are done, you just copy them over and they sit there. And so you need, the one use case for SAS and plotting is you need temporary storage to basically create these plots, because you write a bunch of random data and then you sort that data and then compress it. And that creates a lot of disk IO. And so we recommend basically that people that are doing Chia plotting do this on kind of a high TBW or terabytes written SSD. And typically those are found in data center SSDs. So people have found that you can buy these old SAS or SATA drives on eBay for $50 that have just petabytes of write endurance. And a lot of people are finding out you can buy these small drives, like these old 200 and 400 gigabyte SAS drives for 20 or $30. You can rate a bunch of them together, and that's pretty fast performance. Now, most people are using NVMe because NVMe is faster for SSDs. But a lot of people are using SAS because you can find high endurance old SAS drives very, very easily because they were very common. So as we dive into the SAS infrastructure, I saw this. I don't know how familiar people are with what happened in crypto mining with graphics cards, but basically the mining algorithms that they use for graphics cards aren't very PCIe IO intensive. You don't need a lot of bandwidth on the bus, and so people figured out that you can basically use just a buy one PCIe slot, and you could even go down to PCIe Gen 1 or Gen 2, and you don't need a whole lot of bandwidth. So if you look back up at that table, we didn't even have PCIe Gen 1 or Gen 2 on that table for bandwidth. PCIe has gotten so much faster, and PCIe Gen 3 has been around for over 10 years before Gen 4 came out 2 years ago. But so people in the crypto community basically invented these things to basically hook up very inexpensively to basically hook up graphics cards. They have these PCIe Gen by 1 connectors here, you can see on the left there, and then had a SATA power connector, and then you could also plug in power directly to this PCIe slot, and then it used a USB connection for the PCI Express cable. Like USB is not an approved cable for PCI Express, cables. And there's other people that are using like HDMI cables to transport PCIe for graphics cards. Like this is really dumb. Why is this dumb? Because PCI Express already has cables. And if these people that were developing these graphics mining rigs actually understood that, they would have developed native PCIe cabling that was inexpensive, that didn't require all this overhead and extra fluff. Picture on the left here is, I don't know if these guys actually ever made this, but they announced this like, crypto mining motherboard for Chia, which had a bunch of SATA connectors on the motherboard. And I think that they used like an old Intel chipset, and then they used like a SATA IC to basically, I don't know if it's for Marvell or something, but basically to connect all the other SATA ports. Now, what is wrong with this picture is basically that's you're missing everything important in a JBOD. You're missing the enclosure. Where do you put the drives? You're missing the power supply. You're missing the SAS connections, so we can expand and configure the different types of connections. This thing doesn't include a SAS IC on there, a SAS expander, which actually enables more robust connection to the drives. You're missing the fans. Like this is not useful. So I think people will figure that out. If people are making custom product for Chia, and there's some interesting stuff like this, but you really got to think through the use case. Like how are people going to attach a lot of drives? And again, the exciting thing about SAS is SAS has already solved this problem, because SAS is being used exclusively, as Cameron pointed out, in basically every single data center now. Why is this? Because SAS Infrastructure, a SAS JBOD, accepts either a SATA or a SAS hard drive. So it doesn't really matter. And I'll talk a little bit more about the differences between SATA and SAS hard drives, about how they pertain to Chia in a little bit. But basically, SAS is very easy. And the idea of SAS is you have these JBODs, which have multiple expanders in them. An expander just is in language for SAS. In SAS, you have these initiators, which are generally these host bus adapters. A host bus adapter does exactly what it sounds like it does. It adapts one host to another host interface. So you're adapting PCI Express and PCI Express add-in card to SAS, or serial attached SCSI, which we're talking about today. And these SAS HBAs are basically the initiators that go down to the targets, which the targets are going to be the drives. And with these expanders, you can now, with one cable contains 4 lanes of SAS. And so at SAS 12 gigs, that's about 4.8 gigabytes per second of bandwidth, as you saw in that original table. And that's a ton of bandwidth with one single cable. And so with that one cable, a host can access every single drive. I'm showing a picture of a Supermicro 90 bay JBOD here, but there's a bunch of companies that make JBODs. Western Digital makes their own. Seagate makes their own. Supermicro is one of the largest vendors. There's companies like DDN that do data storage. And so there's a handful of vendors that make JBODs that you can buy. Now, I hope in the future that people make more kind of consumer-oriented type JBODs, for some of the people that have Chia farms that are in their garage or like in the rack in their house. Like, you definitely don't want one of these Supermicro JBODs in your garage or your house. Like, the fan speed is very, very loud, and these things are made to be put in data center racks, and they're basically preset and configured to have the BMC manage the fans so that the fans stay very high and keep the drives nice and cool. Well, this is great for keeping the drives cool, which extends the life of your hard drive, but it's very bad for obvious reasons for noise, right? That you have like 80 or 90 decibels or something absurdly loud. So what you're looking at here is kind of like if you had a single host plotting setup and you're using SAS, you basically would have a NVMe type server. This is like a 1U Supermicro server that has support for 12 NVMe. And so in Chia, really, you just need like one kind of high endurance drive to basically use as your temporary storage. Alternatively, if you have a server that has 512 gigabytes of DRAM, you can do the entire plotting in memory. Now, plotting scales. You can go all the way down. You could plot on a Raspberry Pi. You could plot on a desktop. But the name of the game for plotting is produce as many plots as fast as possible so you can fill up the hard drives. And then once you're done doing that, you never have to do it again. You basically turn off the plotter, move it somewhere else. And so I think over time, this market will go more towards plotting as a service, where people are renting their plotting hardware. People will be able to download plots and move the data around. Just because you don't need the compute for very long in Chia. You just need it once up front, and then once you're done filling up the hard drives with the files, which takes generally takes a month or two, depending on kind of how many hard drives you buy, obviously. But and then you move the data. So once you have this plotting server set up, you put a SAS host bus adapter in there and you hook it up with one cable to the JBOD, and then you can access all 90 disks. And then basically you're just, I mentioned, you're creating these plots and then sequentially copying them over the SAS infrastructure to the hard drives. Now, the good thing about this is there's no network bottleneck. So if you're doing multi-host plotting, or you want to plot really fast, and so like the fastest server today for plotting can plot about, say 25 to 35 terabytes a day. If you have multiple servers of that and you're trying to access the same, host, you're going to quickly hit some bottlenecks, right? Because you're going to quickly either max out this 4.8 gigabytes per second, or you'll max out the 10 gig network on 1,000 megabytes per second. It only takes, writing to 4 hard drives at once. Each hard drive can write, I don't know, if they're empty, they write about 250 megabytes per second on some of these newer, faster hard drives. And so you can easily max out a 10 gig network if you're trying to do this over the network. So the good part about SAS is it scales very well within a couple racks. And you can have SAS cables that are up to 3 meters that are not even active cables, that are just passive cables. And so if you had your plotting servers in one rack and then your farming in another rack, you could have these long cables that connect and you can plot at full speed. And then the good thing about that is you can reconfigure them when you're done plotting. And this is just like a description of like how you would, if you wanted to hook up just one cable, there's generally on the back of these JBODs, you have a primary expander and a secondary expander. And in Chia, you don't really necessarily need redundancy or dual port or high availability. In SAS, remember, SAS is enterprise type hardware. So SAS is basically native for high availability and redundancy. So you have failover to where if a one expander fails, you can have another path to another host. You can fully access the drives. That's nice, but it's a little bit overkill for Chia, just because it's not mission critical data. It's totally random data, and that's one of the interesting, beautiful use cases of Chia is it's not user data, and it's random data. So you can use like not high quality hard drives. I guess I'll elaborate on that in a little bit, but it isn't mission critical. If it goes down, if you have a failure, it's not the end of the world. You can just replot a drive if you do have a failure. And if you have a SAS expander go down, you can reconfigure it. But it's pretty infrequent, right? The idea for high availability in SAS is really like, 5 nines or 6 nines availability or uptime. And so again, SAS is enterprise type infrastructure that has all this stuff built in. I'm going to give a cool example of just like one of the unique features of SAS. You can do this thing called zoning, and SAS has so many features. When we get into like the differences between SAS and SATA, this is one of the big differences. Is SAS is natively multi-host, multi-device. SATA is single host, single device. And so when SATA was designed for desktops, and when you have a SATA connection to the host, it basically locks that connection. This is how HCI works. And basically for the host controller interface, basically single host, single device. Now SAS with multi-host, multi-device, now you can do all these really interesting things where you have failover, redundancy, high availability, and those use cases where I said where you can access a ton of drives. Now in SAS has this thing called zoning, which I think is really cool. You can basically upload a little configuration file to the JBOD that just says, okay, I want these ports to map to these zones. And it's very easy. You could just say, I want all the ports to map to all the slots on the JBOD to map to port A. I want some of them to map to port A and port B. In this case, this is the example I'm showing here is a 3-zone configuration where you have 30 drives, 30 drives, and 30 drives in the JBOD, and each one maps to a different host into a different connector. And then, so the reason why you want to do this is if you wanted to plot and from 3 different hosts to one JBOD, this is actually the most efficient way to do it because each host will lock those 30 drives. Remember, if these are SATA drives, they can't talk to multiple hosts at once without getting confused. Now, if you plug in a bunch of SATA drives to a JBOD and then plug in 2 hosts to 2 different SAS connectors, all the drives will enumerate on both hosts. But if you try to do I/O to a drive that is locked from another host, it will not accept it. It will reject the I/O. That's just how SATA works. But the zoning allows you to actually kind of chop up this JBOD into 3 different zones and then give it to 3 different hosts. And then each host can have full bandwidth at SAS. So one cable of SAS 12 gigabits per second, again, is 4.8 gigabytes a second of SAS bandwidth. that targets this host. So you have a ton of bandwidth for plotting. And again, if you have a server that's plotting 25 or 30 terabytes a day on a super high-end server, you don't want to be bottlenecked by the interface. You don't want to be bottlenecked by the network. You want to be bottlenecked by the sequential writing to the hard drives, which is the actual end media where you're trying to fill them up. So, and again, if with SAS, with one connection to 4.8 gigabytes per second, you can easily, saturate the bandwidth. You don't need to write to all 30 drives at once, but you can certainly write to 4 or 5 at once without being bottlenecked, and that's really all you need. So this is kind of overkill. A lot of people will not need to do this, but if you have a bunch of compute and you want to fill up a JBOD as fast as possible, then this would be like the absolute fastest way to plot, because there's absolutely no network bottleneck. Again, in storage, you call this DAS, or direct attached storage, because the storage is directly attached. Now, one of the cool things that you kind of notice here in this zoning configuration slide is that when you have zone 1, zone 2, and zone 3 on ports A, B, and C, you can set it up to where port D accesses all zones. And this is super useful. So after you're done plotting, you can basically just, and what this is an example of what I actually do, is I'll move the actual physical cable from port C to port D. And then now you can have, again, for farming, you don't really need a lot of compute. You just need kind of like very low amount of, it's like almost no compute, right? You need like one core. So after you're done plotting, you really generally want to take that plotting server or plotting desktop or whatever you had that was plotting that is kind of a higher end system that you don't need anymore. You kind of move that somewhere else or sell it or use it for something else. And then you want to set up a different kind of low end server or just a desktop with an HBing in there for farming. And then all you have to do on the JBOD is move it from port C to port D. And then now this host can access all 90 drives or however big the JBOD is. And that's really slick. Now, the other thing that SAS allows you to do is this thing called cascading. And for farming, because farming is very lightweight IO, you don't need a whole bunch of host bandwidth. For farming, it's very lightweight. I mean, I'm in the middle of writing a paper on just how lightweight it is, but it's 1/1000th of the lowest rated hard drive workload. I mean, it's like 0.4 IOPS. So, I mean, it's like the lowest workload of all time. And so you don't really need very much IO once you have the drives farming. You really just, the goal of SAS infrastructure for farming at that point is to, how do I hook up as many drives as I can with one host? And there's a certain point where the software kind of starts breaking. Like there's some things written in Python that don't scale to 500 plus drives, but they do scale to a couple hundred drives. And a configuration where you have, for instance, like 2 JBODs or 3 JBODs is definitely not out of the question. And so in this configuration here, I have a host where you have a 12 gig SAS HBA. This is a picture of an LSI 9300, which was a very popular HBA. You can basically connect one cable to port A, and this is in a non-zoning configuration. And then you'd have a port C hooked up to port A on the other JBOD. And now this one single host can access and see 180 devices. And Cameron will have to remind me what the actual SAS limit is for number of devices per initiator, but it's like hundreds of devices. So
I think it's in thousands.
Yeah, so it's really not a SAS problem. It's really, you start hitting other bottlenecks like Python and other things in the Chia farming workload before you hit a SAS bottleneck on how many drives you can attach. So this is a pretty standard configuration for like a high-end Chia farmer like that wants to go to multi-petabytes as a cascaded configuration. The other configuration, obviously, an HBA has 2 ports on it. You can hook up one JBOD to one port and then another JBOD to the other port, and then you can have kind of 180 drives per host, direct attach with no cascading. That's also a very good topology that is used very often in Chia. So, the other thing that I think people understand about SAS is, so Cameron mentioned that the number one most important part about SAS is that SAS infrastructure, or the backplanes, expanders, the actual SAS protocol itself, is backwards compatible with SATA. And that means you can plug a SATA device into SAS infrastructure. And it does not work the other way around. You cannot plug a SAS drive into a SATA host. That does not work. And there's a couple reasons for that, right? So one, I mentioned SAS is the number one difference between SAS and SATA is this multi-host, high availability, redundancy, HA. SAS is an enterprise class technology, and that's just not needed in desktops. So none of that stuff works in SATA. And so a SAS drive, a SAS hard drive or SAS SSD has 2 ports. And you could have a 4-port drive. I don't think that it's in the SAS spec. I don't think really anybody makes them, but you can have a drive, a common SAS hard drive, which again, hard drives are what you use in Chia farming right now because they're cheap. A SAS hard drive has 2 ports, and you could have a drive where you plug it into one of these enterprise class JBODs where you could actually talk to 2 hosts at once. Now, this doesn't really matter for Chia because generally for Chia farming, you just need 1 host. In Chia, there's this service called a harvester. The harvester is a background service that runs in the Chia application that basically checks the hard drives for these cryptographic proofs, and it's very lightweight, and you don't really need any high availability or anything for that. So dual port is typically not used in Chia farming. But and then the other thing about SAS, obviously, is that SAS is faster, right? SATA, there's no roadmap for SATA after 6 gigabits per second, so that's it. SATA does not get ever faster than that. But SAS goes to 12 gigabits per second, and then 24G, which is the next gen SAS, which Cameron talked about. It basically doubles the bandwidth again from SAS 12 gigabits per second. Now, on a hard drive, if a SAS hard drive has this, one of the cool things that they have, these things called frame buffering. Let's see if I go back to my picture of a JBOD. So say you have a JBOD. Let's see if I can find a picture with drives in it. Okay, so say you have a JBOD filled up with 6 gigabit per second drives, and you have the host, the expander is 12 gigabits per second, and the HBA is 12 gigabits per second. Well, the expander and the host can talk at 12 gigabits per second, while the expander talks downstream to the drives at 6 gigabits per second. This is a thing called frame buffering in SAS. But that means you can have 6 gig SATA drives in an expander in a JBOD, and you can have full 12 gigabits per second by 4 bandwidth to the host with 1 cable. And in 24 gig JBODs, you'll be able to have 24 gigabits per second with 1 cable to the host with one cable. So this is really, really nice. So SAS is faster than SATA. But on the drive side, so on an SSD, this matters because SSDs can actually saturate bandwidth that is greater than SATA, 6 gigabits per second. So SATA 6 gigabits per second maxes out at 560 megabytes per second. And you can max out that with like a 200 or 400 gigabyte drive. So as SSDs got bigger, 1 terabyte, 2 terabyte, 4 terabyte, and NAND got a lot faster, obviously you needed to move to a different interface that was much faster to support that faster NAND. So NVMe is kind of where most of the market has gone for like high performance SSDs, but a SAS SSD is still much faster than a SATA SSD, at least by about 2x. Usually SAS SSDs are 12 gigabits per second. So on a hard drive, does that matter? No, because hard drives are limited to about 200 to 300 megabytes per second sequential bandwidth just because of the actual rotating media. And so you're not going to be really limited by the interface bandwidth. But so SAS is not a huge advantage there. Okay, so what's left? The last thing about SAS, which makes SAS a little bit more complicated than SATA, is there's a ton of options in SAS. So SAS has a ton of log pages. SAS has a ton of these things called mode pages where you can set up these different settings. And there's some interesting stuff that we've been looking into for power optimization. So there are some trade-offs in Chia where if you use these bigger file sizes, the drive gets accessed a little bit less frequently. And I mean, the drive is already not doing very much I/O. 0.4 IOPS for anybody who's in the storage world is like nothing. That's like no workload. It's like 6 kilobytes a second is your average workload for like an 18 terabyte drive. It's nothing. But the drive does stay in active idle, and what we call idle A is what the hard drive guys call it, and where the heads are doing a track follow around the platter. And in Chia, if you use these bigger files, then you can kind of the drive is idle for more time, and the hard drive can actually park the heads to save a few watts of power. And SAS offers a little bit more configuration on some of these types of settings. Again, this is very like drive dependent and like drive model specific. So I can't give any like sweeping claims about what people can save, but there is some options to save power on some SAS drives. So the net of it, the other thing is error reporting. So I recently did a video, and I'm working on a blog post that will be up on chia.net soon on how hard drives fail and reading the smart attributes. And I'll have some data on how to do that on a SATA drive and how to do it on a SAS drive. They're just different. SATA has smart, and there's a device statistics log page that tells you where all the things are in there. SAS has log pages. In SAS, they call them defects. In SATA, they call them reallocated sectors. So there's just like some terminology differences. But basically, there's no. It used to be the case where SAS was like eons ahead of SATA in error reporting and logging. Now SATA is like pretty much caught up. So I say SAS probably still has a slight edge there, just because it has a few more log pages than SATA does. But for Chia farming, what's the best hard drive? It's the cheapest one. So Chia can use, I mentioned, so Chia 1 is a very light workload. So you kind of just want to use but you want high capacity because they're very energy efficient compared to low capacity. Right now there's a lot of like 4, 6, and 8 terabyte drives that are being sold that have been aging out of data centers that are 5 years old. Those are about as low as you want to go for Chia. You don't really want to go, even below 4 terabytes is kind of on the edge of like, not as power efficient as you'd like it to be. Obviously, that's one of the reasons why hyperscale data centers go to higher capacity drives. Obviously, they have growing data demands to go to bigger drives, and then they want to get the power savings and the TCO savings by bigger drives. But if you can get older drives for really cheap, then that's kind of like the best drive you want for Chia. And Chia is also a really interesting use case for used storage because I mentioned it doesn't store any user data, and it doesn't read very much data, and it's all random reads. So even if you have uncorrectable bit errors on the drive or reallocated sectors, it's almost unlikely that you'll hit them because you'd have to read the drive for 40,000 years before you hit an uncorrectable. A typical hard drive is rated at an uncorrectable bit error rate of 10 to the minus 15. That means for 10 to the 15 bits of data read, you'd expect one uncorrectable error. And so, in a Chia workload where you're reading a couple hundred megabytes a day, this would take tens of thousands of years. So again, the best hard drive for Chia is just the cheapest, biggest one. So it's kind of what we saw earlier in the year. And so there's not really an advantage of SAS and SATA, but we talked a lot about why SAS is really important, even for SATA drives, because it is the infrastructure and backbone that the SATA drives live in. I mentioned this a little bit, the measure, I haven't measured on a recent system, but, the farming workload, when you're in a pool protocol, basically in interoperability with the Chia pool protocol, which the pool sends these things called partial proofs of space to the drive. The harvester will actually look up these partial proofs of space so often and send them back to the pool operator to say, yes, I really have this storage and improving that I have it. And that whole workload I mentioned is about 6 kilobytes a second or 0.4 IOPS. So it's like nothing. The drive is idle 99.8% of the time. Here, I think I measured 99.75 on some of these drives. I mean, it's nothing. This is a 6-core desktop, and you can see the CPU is like 2%. So it takes like 1 core doing a little bit of work. So that's the really awesome part about Chia is once you have the plots and the hard drives filled up, then the farming is insanely power efficient. It's basically now whatever the power of the hard drive is like the power for farming. So people can farm hundreds of terabytes, even petabytes, for lower power than a single graphics card or than a single AM miner from like a Bitcoin mining. So compared to other proof of work algorithms, Chia is really going to be energy efficient because it uses hard drives. And that's really back to like why do we need another cryptocurrency? Well, because proof of work takes too much energy, and we think proof of space and time solves this problem by using storage instead of proof of work. So I get asked a lot, again, SAS, a lot of other people know SAS for RAID. SAS has these RAID cards, and this used to be anybody who's been like a data center operator, knows SAS RAID card. Like, and that's, basically the tried and true thing to do back in the day. If you have storage, was to RAID the drives together in a RAID 5 or RAID 6. RAID 6 is dual parity where you can, withstand 2 failures. And this gave you a, high durability and high data reliability. So it's kind of hard for people that are moving from enterprise storage to Chia to unthink this, because your default and instinct is to like protect data, and in Chia, like, you don't need to protect it because if a hard drive fails, then you basically just put a new one in, or you erase the data and you wipe it and fill it back up with new plots. the plots are completely fungible, and if one plot goes away, then you can fill it up with a new plot. It doesn't matter. And this, I think the other thing people I get, which is not confusing to me because I understand blockchain, of course, but it is confusing to people that aren't like live and breathe this stuff, is that when you win the coins are stored on the blockchain. Your private key and seed unlock those coins. You can spend those however you wish with any wallet that you have that has access to those private keys. If a plot is just the storing the proofs of space. And if when you prove that you have a winning proof of space, you win the Chia, and that Chia is stored on the blockchain. The Chia is not stored in the plot files or anything. So if you lose a drive, it doesn't matter. Like you just throw it away and get a new one. And maybe throw it away, I mean you recycle it and you send it back to your manufacturer. Now in the in Chia, basically JBOD mode is just a way of people saying, like, in most HBAs, that's like just a way of saying pass through. Or HBA mode, JBOD mode just means like give the drives to the host and don't do any RAID on top of that. Like if you typically add a hardware RAID card in SAS, they will basically, obscure those devices from the operating system until they're, created into a logical RAID array. And you don't want that for Chia. You just want to pass the drives to the host. And even crazier, you just like individual mount points. That way, if a drive fails, there's no blast radius concern of taking down other drives. So like if you do, people do like a RAID 0 of a couple 4 terabyte drives just because they don't want like a million mount points, and that's fine. But like if you RAID 0 drives together, now you have a bigger blast radius than a drive of 1. And so again, this is like all, if you're using a SAS RAID card, you don't need to put the drives in a RAID. That will just add unnecessary overhead for what you need for Chia. So, and so for now, I'm going to turn it back over to Cameron. He's going to talk a little bit about the SAS ecosystem. But hopefully that was helpful for understanding a little bit about how SAS is used in Chia. So.
Yeah, thanks a lot, Jonmichael. Wonderful information. I certainly learned a bunch already. We have a few questions that are coming in already, but a quick reminder, if you do have any questions, then please enter them in the chat box and we'll get to them pretty shortly. On this slide, I'd like to provide a quick highlight of the SAS ecosystem components and some of the vendors that offer these products. The companies shown on this slide here are members of the STA, the SCSI Trade Association, and they've been developing SAS products for many, many years. All these companies work together at SAS Plugfests in coordination with the University of New Hampshire's IOL, their interoperability lab. And they work together at the Plugfest to ensure that the SAS products work together in configurations that are pretty simple, small in servers, as well as large configurations with hundreds or thousands of drives. So that is Plugfests are really, really valuable, and we have one that's wrapping up for 24 gig SAS. The items on this slide highlight some of the enhancements made to 24 gig SAS from 12 gig SAS. We touch on a few of them here at the physical layer and at the protocol or block level. The physical layer enhancements include doubling the effective bandwidth from 12 gig SAS with improved encoding and adding 20-bit forward error correction, or FEC. What the physical layer enhancements deliver are going to be higher IOPS and bandwidth performance, as well as improved reliability. On the protocol side, or block side, the fairness updates help to improve performance across multiple generations of attached devices in larger topologies. This includes SAS SATA, as well as hard drives and SSDs in the same deployment. Storage intelligence enables more efficient streaming and data management for SSDs, and this translates into improved SSD efficiency as well as quality of storage performance throughout the topology. SMP priorities also helps to improve prioritization of configuration and management communications. Okay, in summary, SAS is a really great storage technology for crypto farming and the preferred interface for Chia, as Jonmichael endorses that. SAS vendors work very closely together to ensure interoperability and compatibility between products and configurations up to thousands of drives. It has broad support for both SAS and SATA hard drives and SSDs. That's probably the biggest strength here for Chia farming. And to ensure longevity of your storage investment, each SAS generation is backwards compatible for 2 generations. So this allows you to migrate and update your SAS infrastructure at your own pace, and getting the most out of your investment into the hardware. And lastly, before we get to the questions, I'd like to thank you all for joining the webinar. There's some links here for the SCSI Trade Association and Chia, and also please follow us on social media. So I think we can take a few questions here. Let's see.
Sure. And Cameron, I just want to say one thing about this slide. I mentioned there's, all kinds of different size farmers or small farmers and large farmers, but, people quickly, once you get to like the tens of hard drives, people are quickly figuring out that SAS and data centers have already solved this problem. So, kind of reminder about, where to go for that. And I hope that SAS does get to, there's some more consumer oriented SAS kind of things. I would love to see like a JBOD in the future from some vendor that is like, more amenable to someone's home and kind of like, not enterprise class, like heavy chassis and, EMI and protection and all this stuff. Like it's just not needed for a house, but SAS is really useful for that. Like, again, hooking up a ton of drives with one cable is a lifesaver, and it's like absolutely required. And then, a note on this second bullet is that like, it's very funny. So, cause Chia is like, a lot of people are finding and buying like hardware on eBay, like old JBods and old drives and old HBAs that are $20, and they're hooking them all up together. And like, for the most part, the stuff just works. And it's absolutely mind boggling to me. And it's funny, Cameron and I have been to these SAS Plug Fest, 10, 11 years ago, where you're, sitting there hooking up all these new SAS cables and connectors with all the, at the time, like the LSI and Adaptec cards, and testing them all out, making sure they work. But, really the community in SAS, prioritizes interoperability and compliance. And it really shows when people are buying hardware that's 10, 11 years old, plugging it into a latest Linux kernel, and it just pops up with no problem. So to me, that's just fantastic. And it really shows the showcase of SAS.
Yeah, the amount of investment in ensuring interoperability and compatibility is, I don't think there's another technology that has done it this well. Okay, so Jonmichael, let's tackle a couple of questions here. First question is, if hard drive media is spun down and a proof request is made, will this limit the likelihood of winning the proof since there is extra latency in spinning up the media?
Yeah, this is a really interesting question. So, there's a state on hard drives called idle B, where the heads are parked, but the motor's still spinning. And then when there's an IO request, there's an extra, it's like 50 or 100 milliseconds of latency, on top of, instead of like a 5 or 10 millisecond seek time. And that's no problem. That should be no problem. Now, if the drive is actually powered off, that's where there starts to be some challenges, because if you power on a drive, now there's inrush current and the drive has to power up. And typically the spin up time for an average disk right now is about 10 seconds. And theoretically, if you get a challenge, you have up to like 28 seconds, I believe, is the actual time to respond in the next reward block to basically get your valid proof of space into the network. And, with a 10-second spin up time and a 28-second timer, remember that 28 seconds is the entire network propagation time. So you have to find the proof of space. The harvester has to send it to the farmer has to send it to the full node. The full node has to propagate that out in a peer-to-peer to all the other nodes in the network. So it's a little tight. I don't think we recommend, spinning down the drives. And just because the drive's going to be accessed so frequently, it's a little bit too much wear and it's kind of counterintuitive, because the workload is very light and it's not very much IO, but the drive's being accessed kind of frequently because the harvester has to check that your files are still there. And so the drive doesn't generally have that much time to spin down. And the drives are, they're rated for some certain amount of like start-stops cycles. So in general, the best practice today is basically to leave the drive spinning. But you want to go look for these other power type savings of like this idle B, or lower RPM drives can help for the power savings.
All right. Speaking of being green, are there green Chia topologies that may be powered by solar and backed by battery, and that can that be cost effective?
Yeah, there are some Chia farmers that are using 100% solar, which is really exciting. Chia farming already Chia basically consumes about 1/600th of the power utilization of like Bitcoin, for instance. I wrote a blog post on chia.net. If you go to the blog section, you can find one. It's called Mining versus Farming. But I go into all the data here about how we kind of calculate that in the energy use for the Chia network. But even though JBODs and hard drives, these consume real power, like it's nothing compared to Bitcoin and proof of work right now. It's insane. Just for like instance, like Bitcoin mining is at an all-time high right now because the price is going up and everything. All the data centers in the world in 2018 consumed 205 terawatt hours. Bitcoin consumes 200 terawatt hours of electricity annual energy use. Jeez. So that's insane, and that's part of what Chia's mission is to help fix that. And we think hard drives and storage can help do that.
Okay, let's see. This one may be a little bit more geared for me here that I can answer, but it says Jonmichael talked about SAS and SATA hard drives. I've heard of value SAS drives mentioned in previous webinars. Are value SAS hard drives 12 gigabit per second, and will there be 24 gig value SAS hard drives? Well, value SAS is actually an SSD technology. And basically what value SAS is from an SSD compared to a kind of standard traditional enterprise SAS SSD is that it's single ported. It has lower performance than enterprise SAS SSD, but it does provide significantly more performance and reliability than a SATA SSD. So that, to the best of my knowledge, there aren't value SAS HDDs. Probably the closest thing akin to that would have been something called Fat SAS way back in the day, where you basically took a SATA drive and just put a SAS protocol interface, but it basically effectively was a SATA hard drive. Let's see. Okay, Jonmichael. The strength of SAS is the SCSI management protocol, SMP. Do you use SMPs to manage your farm? Why or why not?
Yeah, so I mentioned there's a couple things that SAS has for monitoring that are useful for Chia. So one, the drives themselves have the log pages, and the SMP is just the protocol that communicates back and forth. And so you can read these log pages to find the temperature on the drive. You can find out the error rate, read error rate, write error rate to see if there's problems with the drives. You can look at these defects. Defects will tell you if like the hard drive is collecting defects, meaning it has to reallocate some sectors, and there's physical particles in the drive that are causing physical damage. So there's all kinds of and then other log pages, of course, like latency and whatnot. So those are helpful and useful. And I think the SMP just is the transport that talks back and forth up. And now I have to look at the management application layer, SMP transporter layer, goes in the SAS layer. So now he's going to make me open the SAS spec for the first time. But the other thing we talked about is I wish we would have had more time to talk about today, but it's like I don't know if people would really enjoy me doing SES commands directly from SG3 utils to a JBOD expander, but you can actually send these SES commands directly to the expander, and the expander firmware can manage stuff like fan speed, and it can give you logs on like the power usage of the JBOD or like the voltage for the power supply and all that stuff. So you can do all these actually through the like open source command line tools in Linux. It's a little clunky. Like I would not recommend it for like most people, but all that stuff is actually in the SAS spec and totally works. So,
yeah. Quick one here: is 24 gig SAS really needed? Well, in short, yes, we think so. 24 gig SAS brings a lot of value, especially to an infrastructure. Think of it as a wider, a highway that is twice as wide. It can handle twice as many cars. And really the bandwidth that it provides to an infrastructure really can enable and extend the life of SAS storage deployments and people's investment in equipment. Let's see. How much work has Chia spent associating proof requests to physical devices and locations in the chassis? Or is this work to be done in the future by the open source community?
So yeah, the proofs, it's a total 100% random read. You don't know where. So when if you have a hard drive, and it's say it's an 18 terabyte hard drive, you'd have 165 of these 108 gigabyte files on there. And when a challenge comes in, there's a filter. It's like a 1 in 512 filter. Basically, it's complicated, but there's a hash of the plot ID and the challenge and whatnot. And you basically decide, okay, if a plot passes the filter, then so there's a 1 in 512 chance every 10 seconds that each plot is going to get woken up, and you basically check it. And then when you do the IO to the drive, it basically just does this mathematical equation where it picks these 8 reads from these different tables, and then you hash them together and they form this like partial proof of space. But those reads are completely random. And the reason why they're random is you can't fake the capacity, right? If they weren't random, if they're deterministic, then you could fake the storage. But if it's totally random, you don't get to. You just say, this is the challenge. You have to see if you check all your drives and say, do I have any winning proofs? So that's kind of the exciting thing about the Chia part is, it's not deterministic at all. It's completely random. And so I don't think you could, try to tie any requests to any physical devices. I don't know, maybe I'm misunderstanding the question, but
yeah, this is something that, of course, can be followed up on, reaching out to Jonmichael after this if a question was not answered. One about when 24 gig SAS is going to be available in the market. Like I noted, PlugFest has been ongoing and it's about wrapped up. We may have another one, but in reality, 24 gig SAS is now being offered on HPE ProLiant servers. I think it's already publicly available on their website, and look for a little bit more widely deployed in 2022. So it's kind of trickling in, but right now it's just kind of finishing up a lot of the PlugFest activities. I think we have one more here that Jonmichael can answer. Is there a minimum recommended storage capacity for a Chia farmer just starting out?
No, absolutely. And that's the awesome thing about Chia is you don't need, we just mentioned all these JBODs, and this is if you're like really hardcore into Chia and you want to, have hundreds of terabytes or petabytes of farming. But you can, Chia has this thing called the pooling protocol, which basically you have your basically your plot on your hard drive, and then if you win a reward, you basically send it to the pool, and the pool splits it with all the people in the pool. And this is really nice because then you don't need a ton of storage space to get started. And if you have just one plot or two plot or one hard drive full, you get rewards proportional to how much capacity you're storing on the network. So if you want to just get into Chia and test it out, like the software is free, you just download it, you grab an empty hard drive that you have laying around, or if you have a big hard drive that has extra space, and then, ideally you'd have like a secondary like SSD uses your temporary space you want to buy, like $50 on eBay or something. But if you have an SSD internally, it won't be too damaging to the drive or anything to like write fill a couple hard drives. So yeah, certainly, just if you have some stuff laying around, that's the best way to start.
Okay, and I think we're about at the top of the hour, and I think we've addressed the questions that have all come in. So again, thank you everybody for joining. Thank you, Jonmichael, for joining and sharing your expertise on Chia farming. And please follow us on social media, and don't forget to review and rate the webinar. And with that, thank you all for joining. Bye-bye.
Thanks, guys.